Okay, let's do some quick revision. We've done some binomial expansions before, and I'm not going to spend a long time going over them in this particular video. We're just going to review what we already know. So here are some binomial terms, and I want to expand those. They're in a factorized form at the moment. Now, one method that I have talked about before is the area method, where you can imagine that we are looking at two-dimensional shape, and that each of the sides of this shape are the sections inside of the brackets. Now, if we were to fill out this area by finding this area method by finding the area of each of the individual shapes, well, we would have the area of this shape, and then the area of this one, and of this one, and of this one. And if we look at the corresponding widths and sides, this one would be x squared, this one would be 3x, this one would be 2x, and this one would be 6. Now, as we take all of those different terms, and we want to put them in order, I can't stress enough how important order is in terms of descending indices. So you want to make sure that you have your x squared first, and then your x's, and then your constants. If we had x to the power of 3 or 4 or 5, you'd have them in order. Descending order is very important. So we can then add those two like terms in the middle, and we are going to get our final expression there. This is a trinomial expression. It's got 3 terms in it. I have suggested in the past that the area method is a slow way of doing it, and you're better off doing it with the FOIL method. The FOIL method obviously is much quicker and it's easier. You don't have to draw as much. You would multiply the firsts together. That's the F for first. You would then multiply the outsides, and then you would multiply the insides, and then you would multiply the lasts. And when you wrote all of those things down as you were doing them, you would end up with the exact same thing as we got from the area method. Righto. Then you would also simplify that, and you'd have your trinomial expression. This is the basic way of doing it. The FOIL method is the quick way of doing it. It's probably easier to do. If you can't do it, then you can do it the area method every time, but it'll slow you right down. I do want to talk about a couple of really special instances. I've mentioned these before, but they're worth mentioning again. We have our perfect squares. For example, if I have a plus b in brackets and it's squared, what does that actually look like? Well, it really is a plus b outside of a plus b without that squared bit there. That's really the same thing. I've just written it in 2 different ways. And the answer in every instance will be a squared plus 2ab plus b squared. So if you had something like that, now let's just say we had x plus 2 and it was x plus 2, I can go straight to the answer. It'll be x squared plus 2, well, it'll be 2 times 2, so that'll be actually 4, because it would be 2ab, but one of them is 2, so that'll be 4x plus 2 squared is 4. And that would be the answer. I can go there straight away. Same goes for the other sign for the perfect squares. If it was a minus on the inside, okay, you would end up with minus 2ab. Simple as that. The last one is the difference of 2 squares. This one is if we have a plus and a minus in the 2 different terms. And that one's even easier still. In our instance up the top there, if we had just x plus 2, x plus 2, I can go straight to the answer, and it will be x squared minus 2 squared. And if you think about it, that makes sense. If I was to draw that graphically, I'll do it real quick here. If this is my A-sized square, right? Well, it doesn't really look like a square, but whatever. And I end up actually taking away the B-sized square. So, oh, that didn't go straight. And that's my B-sized square, and I'll end up actually losing that bit of the square, and that would be the area of it, right? That's the total thing. So you can go there straight away in just a very simple, easy step. So they're the 2 special instances: perfect squares and the difference of two squares. So they're important to know and be able to recognise both of those two instances, of those special cases.